Okay, so we are going to go over your Unit 8 review. Please be aware that your tests for Unit 8 will be tomorrow, Tuesday. Okay, a few things that you need to know before we get started. So the mean, another word for the mean is the average, and how you get the average is to add all your numbers together, then to divide by the amount of numbers that you had to add. Okay. The median is the middle number. Okay, but most importantly, before you find your middle number, you must put your numbers in order from least to greatest before you find the middle. And then if you have two numbers in the middle after crossing out from side to side, then you would add them together, add those two numbers, and then divide that number by 2. Okay, so please be sure you do not get more than two numbers in the middle when you're crossing out. It'll either be 1 or 2. So if you end up with 3, then that means you need to cross out your two outside numbers to get 1. Okay, but not more than two numbers in the middle. Your mode is your most common number, the one that occurs most frequently. For example, the one that has the most dots if it was a dot plot. Okay, so whichever one appears the most is your mode. You can have more than one, and you can also have no mode as well. Okay. Range is your highest number minus your smallest number or your lowest number. Okay, so basically the maximum, which is the word for the highest number, minus your minimum, which is the lowest number. Last thing is your interquartile range, or IQR, which is Q3 or quartile 3 minus Q1 or quartile 1. Okay, and that would be whenever you're given a box and whisker plot. For the most part, you can find it in other plots, but for the most part, it'll be when you're dealing with the box and whisker plot. So this is an example real quick of a box and whisker plot. So please be aware of what sections there are. Okay, so this piece would be called the minimum or the smallest number. And the opposite of minimum would be your maximum or your highest number. Okay, so real quick, if you want to find the range, which is the highest number minus the smallest number, you would take the maximum, okay, minus your minimum. Okay, so your very highest number minus your very lowest number would be how you would find the range for a box and whisker plot. Your quartiles would be included in your box. So quartile 1 would be this first line here. Quartile 2, or the median, would be the second line. And then quartile 3, or the upper quartile, would be this last line. So this box right here, this section represents IQR. Why? Because IQR, remember, it is Q3 minus Q1, so it includes the space between Q3 and Q1. So this box represents IQR, or interquartile range. One thing I want to go over real quick is the percentages for each section. Please be aware that each section is 25%. So from your minimum to your quartile 1 is 25%. From your quartile 1 to quartile 2, or your median. Okay, remember the median is that line that's in the middle of your box. That is 25%. From your median to quartile 3 is 25%. And from quartile 3 to your max is 25%. So even if they do not look like they are all equal as far as percentages, because clearly this line here looks longer than this line, you must know that there's still going to be 25%. There's still going to be 25% each, because they are quartiles. And that's pretty much the definition of a quartile. Okay, so no matter if this looks longer, it's still all 25% per quartile. And because of that, that means your IQR will always be 50%, because it will include the two quartiles on the inside. So it'll always be 50% of your data. Okay? All right, so let's get started. Okay, so number 1 says that Melanie started working at Zane's car wash. She recorded the number of car washes for each day during the months of October and November, and she displayed the results in the box plot shown below. Which statement best represents the information in the graph? So we want to know which one basically is true. Okay, so I'm just going to go through these and we'll see which one is true. So A says that the data distribution in October's box plot appears to be skewed right. Okay, so skewed right means basically the tail is going to the right. So real quick, the long tail for October is on the left side. So this would be skewed left. Okay, just as an example. And then the longest tail here is on the right side. So this will be skewed right. Okay, so they're asking about October, and they said October would be skewed right. That is not true because it's actually skewed left because the tail is on the left side. B says that the interquartile range of the two box plots is the same. So remember, interquartile range is basically your quartile 3 or your upper quartile minus quartile 1 or your lower quartile. So we have to find the IQR of both box plots. So your Q3 for October is at 24. And I'm going to subtract the Q1, which is at 22. Okay, so your IQR for October is 2. Now we're going to do November. Your Q3 is at 19. So we're going to do 19 minus your Q1, which is at 17. 19 minus 17 is 2. And so they said that the interquartile range of the two box plots are the same, and that is true. So B would be your answer. Okay, number 2 says, which of the box and whisker plots represent data that has a median of 18, so a middle number of 18, and a lower quartile of 16. Okay, so your median is the line that's inside the box. Okay, it doesn't necessarily have to be in the middle of the box, it's just inside the box. So we want the median to be at 18, so these are your medians inside the box. All right, so we want the one that is at 18. This one is at 20. This one is at 18, and this one's at 24. So I believe the only answer that I can have is going to be plot 2. Okay, because the median is at 18. Let's just make sure that the lower quartile is at 16, which is your Q1, and it is at 16. Okay, so plot 2 would be your answer. All right, so number 3 says that the diameters in millimeters of some bicycle tires and automobile tires are summarized in the box and whisker plots. Approximately how many times the difference between the medians of the automobile tires and the bicycle tires is the range of the bicycle tires. Okay, so they want to know how many times, and then we'll leave that section. Okay, but anyways, they want us to find the difference between the medians of the automobile tires and the bicycle tires. And then they also mentioned finding the range of the bicycle tires. So we're going to find both of those, and then we're going to figure out how many times is this more than this. Okay, so first we are going to find the medians of the tires. Okay, so they want the difference. Remember, difference means to subtract, so we're going to find the medians of both and then subtract them. So the median of the first one, I would say between 580 and 590, so I would say 585 for bicycle tires. And then for automobile tires, it looks like the median is at 840. So they want the difference between those. So we are going to subtract. If I subtract those, I will get 255. Okay, as the difference between the medians of the tires for the box plots. Then they mentioned finding the range of the bicycle tires. Okay, so just the range of the bicycle tires. Okay, and so remember, the range is the highest number minus the smallest number, or the maximum minus the minimum. So your range is your highest number, which is right here, minus your minimum, or your lowest number. Okay, I'm just going to round or try to get a whole number, since I'm not too sure of what the number is that goes a little bit past 620. So I'm just going to round it to 620 as my highest number minus my smallest number. I'm going to round that to 560. Okay, so the range is the highest number minus the smallest number. If I subtract that, I get 60. Okay, so the difference between the medians was 255, and the range of the bicycle tires, as it mentioned, is 60. It wants to know how many more times is this than this. So my last thing is just to divide to see how many more times is this than this. Okay, so I'm going to do 255 divided by 60. See how many times 60 can go into 255. If I do so, I will get around 4.25. And that is closest to an answer of 4. Okay. Number 4, the box and whisker plot shows the average class sizes in 15 schools. Which statement about the class sizes must be true? So we want what's true. So I'm just going to go through and we'll find out. F says that the range of the class sizes is 8. So the range, remember, is the highest number or the maximum minus the lowest number or the minimum. So the highest number, okay, so 32, 33, 34, 35, 36. So this will be 33 is the highest number minus the lowest number. So they're counting by 1. So this is 20, 21, 22. If I do that, I will get 11. Okay, so the range is not 8, it's actually 11. So F would be wrong. G says that the largest class size is 31. That is not true. The maximum or the largest one is at 33. It's past 32. Okay, it's 1 past 32, so it's not 31. H says that about 1/2 of the classes range in size from 23 to 21. Okay, that's where our percentages come in handy. Okay, so remember in the beginning I talked about each quartile being 25%. So I'm going to label that. So from here to here is 25%, that little piece right there. This piece right here is also 25%. This is 25%. And this is 25%. Why? Because that's basically the definition of a quartile. Okay. I like to think quarters. Okay. And because there's 4 quarters in the dollar, that's how I would imagine that each of these 4 quartiles is 25%. Okay. So about half, they say, is between 23 and 21. Okay. So 23 is here and 31 is here. Okay, so they're trying to tell me that this box is half or 50%. Okay, and if you remember from before, I told you that the box or the IQR is always 50% because it includes those two quartiles. And so that is true because this box represents half of my data, 50%. Okay. Okay. All right, so number 5 says that the line plots show the number of public schools in each of 6 countries and 2 different states. Okay, then the question says approximately how many times the difference between the means of states 1 and state 2 is the range of state 2. Okay, so we got that how many times. Okay, but anyway, they mention finding the difference between the means of state 1 and state 2, and then they also mention finding the range of state 2. Okay, and then after that we're going to figure out how many times, so we're going to divide after we find each of these sections that they mention. All right, so let's get the means of state 1 and state 2. Okay, so remember the mean is just the average, and what we do about it is we add all of the numbers together and then we divide by however many numbers there are. Okay, so I'm going to find the mean for both, and then it wants the difference in between them, so we're going to subtract it when we get them. So we're going to add the numbers together. So I have 1, 4, plus I have 110, plus I have 2 11s, so plus 11, plus 11. I have 113, so plus 113, plus I have a 14, so plus 14. If I add those together, I will get 63. Okay, but then remember, for the mean, you are not done after you add. You have to divide by however many numbers that you had to add together. So we're going to divide by 1, 2, 3, 4, 5, 6. So we're going to do 63 divided by the 6 numbers that I had to add together. If I do that, I will get an answer of about 10.5. Okay. All right, so now I'm going to find the mean of this one. So add the numbers together. So I have a 10, plus I have 2 16s, so plus 16, plus 16, plus 17, plus 19, plus 20. If I add those together, I will get 98. Okay, so I get 98, and then you have to divide by however many numbers that you had to add together. So I had to add together 6 numbers, so I'm going to divide by 6. So it's going to be 98 divided by 6. If I do that, I will get an answer of 16.3. Okay, so I have my means. I have 10.5 and I have 16.3. Okay, and so they just want to know the difference in between the means. So I'm going to subtract these two. So I'm going to do 16.3 minus 10.5, and I will get around 5.8. And that is my difference between my means, or my averages. Okay. Then they mentioned finding the range of state 2. Remember, the range is the highest number minus the smallest number. And they want state 2. So it's going to be 20 as my highest number and 10 as my lowest number. So subtract that, I get 10. Okay. And that is my range for state 2. Okay. Now they want to know how many times is one than the other. So I'm just going to divide to see how many times one is than the other. Okay. So I'm going to put my bigger number on the inside. If I divide that correctly, I will get around 1.7. Okay. And so as my answer, and so that is closest, or if I round it, it is closest to an answer of 2. So my answer is going to be J. All right, number 6 says that the graph shows the number of applicants to University Y from 1982 to 1991. What conclusion can be made from the graph? So it has to be something that I can be able to look at the graph and be able to say. Okay, so let's look at real quick the titles that they give. All right, so there's the applicants to University Y. These are the years, and these are the number of applicants. Okay, so be sure to look at your titles and understand what you're talking about. They're going by hundreds here. And then, like I said, these are the years. All right, so let's start off with the first one. This says that University Y never had less than 450 applicants. Okay, so don't be tricked. Okay, I do know that there's nothing here that is less than 450, but this does not include all of the years. Okay, this is only 1982 to 1991. So I can't say that in another year that's not here they had that they didn't have less than 450. Okay, so I can't say that they never had that because I don't have all the years here. I only have a certain amount. Okay, they could have had less than 450 in 1995. Okay, so I can't say that this is true. B says that more students applied in 1991 than in 1987. Okay, so we'll look at 1991. They look to be at about 800, and 1987 looks to be about 750. So I can say that. Okay, but let's just go through and make sure we can't say anything else. All right, so C says more students attended University Y in 1986 than in any other year. Well, I do have 1986 as the highest, but like I said, don't be tricked because I can't say that it's higher than any other year because I don't have all years here. I only have a certain amount from 1982 to 1991. So in 1980, it could have been more than 1986. Okay, so I can't say that it's more than any other year because I don't have all the years here to be able to say that. And then D says that the economy in 1986 was stronger than from 1982 to 1991. Okay, this has nothing to do with the economy. So the applicants or the people who applied to the university has nothing really to do with the economy. So I can't say that that's true either. Okay, so I can't say anything about the economy from looking at this. So your answer would be B, that more students applied in 1991 than in 1987. I can definitely say that that's true because that is here. Okay. All right. So number 7 says, which statement is not supported by the data? Okay. So we're just going to go through and make sure that we're looking for the one that is basically not true. Okay. All right. So A says that 50% of the spaces are green. Well, we have 2 greens and they are each 25%. So if I add that, that is 50. So that is not our answer because we want the one that's false. B says approximately 1/8 of the spaces are yellow. Okay, so I have this percentage that is yellow. I'm just trying to figure out, is that the same as 1/8? So that means I have to convert from a percent to a fraction. Okay, and so the first thing I'm going to do is try to get this into a decimal. Okay, if you were here last year, then hopefully you've heard of Dr. Pepper. If not, it just means you're basically, if you want a decimal from a percent, you would move your decimal to the left twice. Okay, so I would go 1 for the 2 and 1 for the 1. And so the decimal would be 0.125 because it moved in front of the 1. Okay, and then I want to get a fraction from this decimal. If you were here last year, you might have heard of write it like you say it. So pretty much I'm going to say this using my place value. So I'd say 125 thousandths. And so I would write it like I just said it. So 125 over 1,000. And then I would simplify. Okay. Usually I will go with the number that's on top and hopefully it'll work perfectly without getting a decimal. Okay. And so 125 divided by 125 is 1. 1,000 divided by 125 is 8. And so the fraction would be 1/8. Okay, and so that is my answer. Number 8 says that Justin surveyed 100 people at his school about their favorite pet. The results are shown in the pie chart below. Which best describes the results of his survey? Okay, so we want the one that is true. All right, so A says that about 60% of the people surveyed prefer dogs. Okay, by looking at this, I can tell that half of this is dogs, which usually is 50%, not 60, so it's not A. B says that about 30% of the people surveyed prefer cats. Okay, so if I look at this with cats, it's a little bit more than a quarter. Okay, remember a quarter is 25%, so it's a little bit more than 25%, so I would pick B as my answer. So about 30% of the people surveyed prefer cats. Okay, so a little bit more than 25% prefer cats. Okay. Okay, so number 9 says that the graph below shows the number of bicycles sold in a 6-month period by Darnell's Bicycle Shop. Based only on the information in the graph, which statement is valid or true? Okay, so we want to know which one is true. So we're just going to go through them and see. A says that October was the worst month for bicycle sales. Okay, before I do this, we just got to make sure we go over the titles and what they mean before we understand this data. Okay, so this is monthly bicycles. The months are here and the number of bicycles sold are here. Okay, and then be sure you understand what these numbers are. Okay, whether they're counting by thousands, millions, or whatever. It doesn't seem to say so, so we'll just take it as it is. All right, so A says October was the worst month for bicycle sales. Well, October was the worst month. No, it was not, because January had less. Okay, so that is not true, because there was less in January than October. B says that the cost of a bicycle was highest during December. Okay, well, if we are looking at this, it says the cost. Okay, well, this does not represent the cost. This is the number of bicycles sold. So please be careful on that. So even though this is the highest bar, it doesn't represent the cost. It represents the number of bicycles sold. Okay, so that is not true. So be sure to understand that. C says bicycle sales increased every month from September through December. Okay, it did not, because from September to October it actually went down or decreased, so that's not true either. And then D says more bicycles were sold during December than in October and November combined. So let's see how much was sold in December. If I look at it, it's about 200. And then they said it's more than October and November combined. So in October, it seems to be 50. And we're going to combine that. So we're going to add that to November, which was 100. If I add that, I get 150. So December was more than October and November combined, because 200 is more than 150. Okay, so D would be your answer. 10. The graph below shows the number of internet users in 6 countries in 2005. It says, which of the following is a true statement regarding the data in the graph? And whenever we're dealing with true, I just go through each of them until I find the one that is what they are asking for. Okay, be sure that you go over the titles. Okay, so this internet users in 2005, these are the countries, and this is the internet users in millions. Okay, so this is not 50, this is 50 million. Okay, this is 150 million. The highest number that they put on this graph is 250 million, not 250. So be sure you understand this is millions. Okay, this is in millions for this axis. All right, so China, F says China had about 120 internet users in 2005. China. Okay, all right, so if I look, okay, this does look to be counting by tens for me to get to 150, but it is at 120, but remember, this is 120 million because we're counting by millions, so it is not 120. It is actually supposed to be 120 million. Okay, so F is not right. G says Germany had about 20 million fewer internet users than India in 2005. Okay, so Germany had 20 million fewer. So Germany seems to be around 45 million, and then India is at 50. They said that was 20 million fewer. That's 5 million fewer, so that's not true. Okay. H says that Japan had about 85 million internet users in 2005. So Japan, okay, so I would say 50, 60, 70, 80, and then in the middle, so 85 million. That does seem to be correct for Japan at 85 million users. Okay. Okay, so we are going to continue with number 11 in the next video, so be sure that you catch that. Okay.